Hello, math humans. We're going to do 8.2b today. We're going to be doing matrix multiplication. And, yeehaw, we're going to do that matrix multiplication by hand. So matrix multiplication works if and only if, I love that saying, the interior dimensions match. So let me show you what I mean. So let's say you have matrix A is a 2 by 3 and matrix B is a 3 by 4. If I want to do A times B, then that is the 2 by 3 times the 3 by 4. The inside dimensions match, which means the multiplication is possible, and then your solution matrix is going to be a 2 by 4. So let's see what happens if I tried to do B times A. I would have 3 times 4 times 2 times 3. Notice that the interior dimensions don't match, so this one is not possible. So when you're going to do matrix multiplication, the goal is to always check before you do any math to see if the operation is actually possible. All right, so let's start our first example. And I'm going to tell you that A is 1, 2, 3, 4, 5, and 6. Not very creative numbers, sorry. And B is going to be 7, 8, 9, 10, 11, and 12. Okay? And I want to find A times B. For me, when I do matrix multiplication, I like my matrices written side by side because I think that helps a little bit. When we do matrix multiplication, it's going to be row by column. Okay, so we'll just do it one at a time. Actually, let's check. So this is a 2 by 3, and this is a 3 by 2. The interior dimensions match. Notice that my solution is going to be a 2 by 2. So when I start doing the work, it's going to be 1 times 7 plus 2 times 8 plus 3 times 9. This is going to be the first element. And then I'm going to do row 1 by row 2. So 1 times 10 plus 2 times 11 plus 3 times 12. So there is my 2. And then for the second row, it's going to be the second column by the first row. So 4 times 7 plus 5 times 8 plus 6 times 9, and then the second row by the second column, so 4 times 10 plus 5 times 11 plus 6 times 12. Now, if you're showing your work, which you should be, one thing that's really kind of nice to notice, I got all my crap out of the way, is that the numbers line up. If the numbers don't line up, that means you screwed up and you need to go back and fix it. So then if you do all of this math, you're going to get that this is 50, 68, 122, and 167. And I would do that math in my handy-dandy grapher. Okay? Let's do example number 2. And for this one, A is going to equal negative 1, 3, 4, negative 2, 5, and 0. And then my B is going to equal negative 3, 2, negative 4, 1. And again, I want to find A times B. So let's check the dimensions. This is 3 rows by 2 columns. Okay? And then B is a 2 by 2. My interior dimensions match. My solution is going to be a 3 by 2. Okay? So if I start doing the work, it's going to be the first row by the first column. So it's going to be a negative 1 times a negative 3 plus 3 times a negative 4. And then it's the first row by the second column, this one. So negative 1 times 2 plus 3 times 1. Okay? So remember, it's going to be 2 wide. So I just found there's my 2 wide. Okay? I'm going to draw my matrix. The second one is going to be second row times the first column. So 4 times a negative 3 minus 2 times a negative 4. Notice my numbers are matching. And then 4 times 2 minus 2 times 1. And then switch to a different color. Third row, first column. 5 times a negative 3 plus 0 times a negative 4. And 5 times 2 and 0 times 1. And if you do all of that math, you're going to get that this is negative 9, 1, negative 4, 6, negative 15, 10, and this is A times B. Alrighty? So now let's do one more example okay, for this portion. So example number 3 says A is equal to, and the matrix is going to be negative 2, 1, 1, negative 3, 1, and 4. And notice this is a 3 by 2. And then B is going to be negative 2, 3, 1, 4, 0, 1, negative 1, 2, 2, negative 1, 0, 1. And I want to find, not too creative, A times B. The dimensions of this guy, there are 3 rows and 4 columns, but notice that the interior dimensions don't match, so I'm going to write not possible. It is always in your best interest to check the dimensions first, because otherwise you're going to give yourself a lot of work that you really didn't need to do. So now I want to do matrix multiplication in your grapher. So I want to do a couple of examples to show you how that works. So I want to have A is equal to 1, 2, 3, and 4. Again, not very creative numbers on my part. B is going to be 5, 6, 7, and 8. And I want to find A times B. Okay? So I'm going to go into my calculator, and I'm going to go into my matrix, and I'm going to edit A, and it is a 2 by 2. And I'm going to enter the numbers 2, 3, 4. Okay? And then I'm going to quit. I'm going to go back into matrix, and I'm going to, oops, sorry, my bad. I need to edit, and then I can do B. And B is a 2 by 2. Okay? And it is, oh, look, those numbers are already there. That's lucky me. So now that I have both matrices in my calculator, what I want to do is I'm going to do second matrix, and I'm going to choose A. And then I'm going to do second matrix, and I'm going to choose B. And I'm going to hit enter. And so notice that it gives me my answers, 19, 22, 43, and 50. And then I record those. I did not check the dimensions, but if you put your matrices in and then attempt the multiplication without checking your dimensions, you'll either get, I think you get an error in your calculator. Notice that when I put the multiplication in, I didn't put a times symbol in between the two matrices because your calculator understands that things that are side by side are multiplied together. Alrighty? So now let's say I want to do second matrix and I want to do B, and I want to multiply by second matrix A. And notice when I do B times A, I get a completely different matrix. So unlike regular multiplication, A times B is not necessarily going to equal B times A. It's possible, but it is not commutative. So matrix multiplication is not commutative. M-U-T-A-T. Whew, that's a long word. Okay? There's a special kind of matrix that I want to talk about, and it is called an identity matrix. Okay? And we talked about this in the last chapter when we did when we chose not to do Gaussian elimination, but the identity matrix is always going to be a matrix that has ones on that left to right diagonal. if I had a bigger matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1, okay, that is also an identity matrix because the ones are going from the left to right diagonal. If I do the opposite diagonal, it has a different effect, and that is outside the scope of PreCalc, so we're not going to talk about it. An identity matrix can be any size, so I could even go 1, 1, 2, 3, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. Okay, so that the matrices can be any size. An identity matrix is the same effect as multiplying by 1. So if I multiply a simple number by 1, I get 3. Well, if I take a matrix and multiply it by the identity matrix, I get the original matrix. So if you wanted to experiment, if you put A is 1, 2, 3, 4 in your calculator, and you put B in as 1, 0, 0, 1, when you do A times B, you're going to get A. So that's actually kind of cool. Alrighty. Okay, I think that's it for today. That was a nice, short, and simple process. I will tell you that on matrix multiplication by hand, you need to be very careful to write down all of your work, because if you try to skip steps, that's when we make mistakes. All right, my dears, have a good day, and I will see you soon.